Okay, so this example again is taken from the RC Hibler book, and this is also one of the example in your tutorial sheet. So in this case, the two discs A and B having masses of 3 kilogram and 5 kilogram. So the mass of A is 3 and the mass of B is 5. If they collide with initial velocities shown, so the initial velocities are given, determine their velocity just after impact, and the coefficient of restitution is given, which is 0.065. Okay, so in this case, what you are given is that okay, so MA is given, which is 3, MB is given, which is 5. You are given VA1, which is 6 meter per second, and you are given B1, which is 7 meter per second, and you are also given theta, which is 60 degrees here. So in this case, you are also given that this is the line of impact, and the plane of impact will be obviously in this direction here. So if you draw this these two particles here, so these are their center of gravities. So if you just draw this line, this is our line of impact, and this is the plane of impact here. We will call this our n direction, and we will call this our t direction here. So in this case, this is obviously oblique impact, because the velocities of this disk B is in this direction here, and the velocity of VA is obviously in the line of impact. Okay, so in this case, the velocity of this one is coming in this direction. So this is we can call this VB, which is equal to 7, and this angle is given, which is 60. We can obviously split this velocity into two components in n and t direction. This angle is 60 here. So this will be VB VBT, and this will be VBN. And similarly, if you consider this this body here, disk A, so the velocity of disk A is in this direction. We will call it VA here. So this is our disk A, and this is disk B here, and this velocity is 6 meter per second here. Okay, so in this case, what we can do is that we can calculate the normal and tangent component of these velocities here. So for velocity A before impact, we have this VA, and the velocity of B before impact is VB. But just to say that in this case, we need to calculate the final velocities after impact. So the requirement here is we need to calculate VA dash, and we need to calculate VB dash. So that is their magnitude and also the corresponding angles there. So we will need to calculate theta A dash and also theta B dash here. So we will need to calculate these four unknowns here. So the magnitude of velocities after impact of the two disks and also their directions. Okay, so the first thing that we're gonna do is to find out the component of these velocities before the impact. So for A, it's straightforward. For A, we can say that VAN is 6 meter per second, which is in the positive direction here, and there is no t component here. So therefore, VAT will be 0 meter per second. Similarly, for disk B, we will say that VBN, which is this thing here, VBN is this one, so which will be 60, 7 cos 60, and obviously it's in the negative direction, so it will be minus 7 cos 60, which will be minus 3.5 meter per second. And the VBT, which is this thing here, it will be minus 7, which is again in the negative direction, so minus 7, and sine 60 here. So this will be minus 6.06 meter per second. So we calculate these directions, velocities here. Okay, so now we can now apply the equations and try to calculate the different components after the impact. So the first equation that we can apply is the law of conservation of momentum to the whole system. And obviously we must specify the direction, which is what we taking is positive. So if we take this direction is positive here, so before impact we have and obviously this will be applied in the normal direction, so G1 n equal to G2n. So this is the momentum before impact and after impact in the normal direction. So in the normal direction, we have mVAN plus mVBN equal to MA, this is MB. We have this equation here, and this equation is only applicable in n direction here. So if we just put the known values here, so what we know is MA, which is 3 into 6, plus MB is given, which is 5. And again, you are given this VBN, which is minus 3.5. And on the right hand side, you have 3 VAN dash and plus 5 VBN dash. So we just get this first equation here. So this is our equation 1. Now, as we know that the second equation that we can get here is from the coefficient of restitution. And again, we will take this is our positive direction. So E is equal to, we know that it's VBN dash minus VAN dash divided by VAN minus VBN. This is the equation of the coefficient of restitution. So we can put here the values. So it will be VBN dash minus VAN dash divided by 6 minus, and it is minus 3.5. And E is, we know that it's 0.65, which is given. So from here we can calculate VBN dash minus VAN dash, which will be 6.175. So this is our equation 2. Okay, so now we have two equations. One is this equation here, and one is this equation here. So we have two equations, and there are only two unknowns in this equation. So one is VAN dash and VBN dash, and again VAN dash and VBN dash is here. So we can calculate VAN dash and VBN dash from these two equations. So if you solve these two together, so from 1 and 2, so from equation 1 and 2, what we will get VAN dash, which will be minus 3.8 meter per second, and VBN dash will be equal to 2.378 meter per second. Now if you look at this value, so VAN is negative and VBN is positive. So the direction, this equations will also provide you with the directions here. Okay, now we managed to calculate VAN dash and VBN dash, but now we also need to calculate the tangential component of the velocities. So if we consider the tangential component, so we know that for oblique impact, there is no force in the t direction. So then the for each disk, the momentum will be conserved in the t direction. So if you consider, for example, this is our positive direction. So for particle A, what we will write this is MA, or simple is G1T plus G2T. So the initial impact will be equal, initial momentum will be equal to the final momentum here. So in this case, you can write is MA VA so MA VAT, and then so this is before impact and this is after impact. So in this case, obviously you can cancel this thing here. So here what you will get is that VAT dash, because VAT is 0, so this will be also 0 meter per second. And now we need to calculate for the second particle, so which will be again G1T will be equal to G2T. So G1T will be before impact and G2T will be after impact. So which will be MB VBT equal to MB VBT dash. So again, we can cancel MB with the MB, and VBT dash will be equal to minus 6.062 meter per second, which is this value here. So we managed to calculate all the component of the velocities. Now we can calculate the final velocities here. So in case of particle A, as you can see is that we have two components. One is this component here, and so these are all the components of the velocities. So two are these components and two are these components. So now for velocity A, if we draw the components, so this is our n direction, this is our t direction. So for VA, we only have velocity which is in this direction, which is minus 3.8. So VA dash will be equal to 3.8, and it's just going in this direction here. So the angle associated here is 0 here. So there will be no angle with respect to the normal direction. It's just going in this direction here. Now for the other part, again you can draw. So again, if you say that this is your n direction and this is your t direction, so as you can see for VBN, for the VBN, the n the n is positive, so which is 2. So which is positive here, so which is 2.378, and then the VBT is negative, so you should go in this direction here, which is 6.062. And then you need to calculate this angle here. So this angle, if you want to calculate the VB dash, so VB dash will be just equal to VBN dash square plus VB t square under the root, and this will provide you with the 6.51 meter per second. And then the angle, which is theta, this should be equal to tangent inverse, and obviously it will be this value divided by this value here, so which will be VBT dash divided by VBN dash, which will be 68.6 degrees. So here you manage to calculate the velocities after impact. So velocity of disk A, which is 3.8, and again it's moving in the n direction, but in the negative n direction here. And disk B is now moving in this direction here. So if you consider the original figure, this figure here, so you can see that the disk A will move along this direction. So VB VA dash is in this direction here, and this body will move in this direction here. So this is our VB dash.